Hello, I saw your question on the discussion board about how to come up with this. Identities can be challenging. With practice, you get better, and there's multiple ways of working these. Of course, that you don't. They don't give you really one option here. In reality, there's many ways to work this to show this is true. So they start with this, and it looks like you had a little bit of problem going from here to here. Now this is correct, the justification. You do want to combine using the least common denominator. And so if you look here, this one has a secant of theta denominator, this one has a tangent of theta. So their product will be the least common denominator. So I take this first term here, and I multiply it by tangent of theta over tangent of theta. Then I take the second one, and I multiply it by the secant of theta over secant of theta. That'll give you a common denominator. And so in the numerator, you need to distribute the tangent, so it'd be secant theta tangent theta. Then you distribute here, it'd be tangent squared of theta. And over the product of secant theta tangent theta. Plus, then you got to repeat it here, secant of theta times tangent of theta. Secant theta times secant of theta be secant squared of theta, subtraction. Then over the tangent theta, secant theta. And so, from here, you can see they have the same denominator, so you can write them over the same denominator. You can combine this one and this one, and that gives you, if you combine these two, that gives you 2 secant theta tangent. Then you're left with this tangent squared of theta minus this secant squared of theta. They actually pull a -1 here, factor a -1 out. If you distribute, that'd be a minus secant of theta and a plus tangent squared of theta. Okay, and so that's how they arrive at this. Why did they do this? So you could use a Pythagorean identity, and if you use Pythagorean identity, that'll be 1. So your next step here, you do want to divide out the common factor. So I write this first term over secant theta tangent theta minus, and I go ahead and put 1 in there, secant of theta tangent theta. Then from here, you don't divide out the common factor, and you'll be left with the 2. And here, you just use the reciprocal identity for secant and tangent, and I guess you get cosine and cotangent. And so there are really many ways to work it, but we got to follow the way that they're wanting us to do here. We don't have an option. Hope that helps.